So hello, good evening all of you. Can you all hear me? Good evening all of you. Please type in the chat box. Can you all hear me? Good evening everyone. So please type in the chat box. Can you all hear me? Yes or no? I need some responses. Please type in the chat box. Can you all hear me? Yes? Okay. Yes. Okay. So in yesterday's class, if you quickly recall, we have discussed something on differential equations. So we have seen what is different classification of differential equations, and we have seen what are ordinary differential equations, and then we have seen what are partial differential equations, correct? And in ordinary differential equations, we have seen how to identify homogeneous equations in case of first order differential equations, and also we have seen how to identify homogeneous equations in higher order differential equations, correct? And after that we have seen what is linear differential equation, and also we have seen what is non-linear differential equation, correct? And then we have solved few questions on order and degree of a differential equation, and we have seen solving few questions using solving few first order differential equations using variable separable form, correct? This is what we discussed in yesterday's class. Can you all recall this? Can you all recollect this? And can I continue today? Can you all recall this? We have talked about order, degree, and then we have talked about homogeneity and non-homogeneity of differential equations. Then we talked about linearity or non-linearity of differential equations, and finally we solved a few questions on first order differential equations which can be solved using variable separable form, correct? So this is where we stopped yesterday. So we have seen if the function is of the form, okay. So we have seen if the function is of the form f of x comma y is equal to dy by dx or dy by dx is equal to f of x comma y, then in a special case, whenever this function can be split as a product of some function of x and some function of psi is equal to dy by dx, then we have seen how to convert this into variable separable form, and we have solved this kind of questions. So in today's class, and of course this is a homogeneous equation if this f of x comma y is a homogeneous function of degree 0, correct? This is the definition that we gave. If you want to call this first order differential equation dy by dx is equal to f of x comma y, did we mention that this f of x comma y should be a homogeneous function of 0th degree? Yes or no? Did we talk about this? Please respond. Correct? Good evening, Dinesh. So this is what we have talked. So in today's class, we'll talk about non-homogeneous differential equations and also some few special kind of first order differential equations. Okay, so non-homogeneous differential equations. So sometimes there could be a chance that this dy by dx is equal to some non-homogeneous functions, correct? So for example, if I call ax plus by plus c divided by a dash x plus b dash y plus c dash, if you see this expression or this expression ax plus by plus c is a non-homogeneous term, correct? Because if you see the degree of x is 1, the degree of y is also 1, but there is a constant. So you can't take some you can take some k common out of all these things. So this is non-homogeneous. Similarly, non-homogeneous, and similarly this which is in the denominator is also non-homogeneous, correct? So there could be some cases where you will be facing equations of this kind, and we'll see how to solve these kind of equations. Of course, because they are a bit lengthy, they are not being asked in GATE examination, but it's our responsibility to learn something about this. Okay, so let us talk about a special case. We have the differential equation of the form ax plus by plus c divided by a dash x plus b dash y plus c dash. Now there could be some special case where I would like to discuss under case 1. This a by a dash will be equal to b by b dash. Okay, you will be having something like this. For example, if there is a homogeneous a non-homogeneous differential equation such that the ratio of these two quantities is same, correct? Then what you can do, suppose if you take this as k, you can write this a dash is equal, or a is equal to a dash into k, and similarly you can write b is equal to b dash into k. This is what you can write, correct? So now if you compare this dy by dx, this is equal to, in place of a you can write a dash k, so k times of a dash x plus b dash y plus c divided by k times of In the denominator you don't have a k, so a dash x plus b dash y plus c dash. This is what you have. Now by taking this a dash x plus b dash y is equal to some variable, then if you substitute this dy by dx as dt by dx from this particular equation, see, you can differentiate, correct? A dash plus b dash into dy by dx is equal to dt by dx. So you can substitute this dy by dx in terms of dt by dx from this particular equation, and also if you replace this a dash x plus b dash y with t, then this equation gets converted to variable separable form, and then you can try to solve this. Okay, but of course I'm not completing this because I haven't given any numerical values at this moment. So but if you have any case like this where the ratio of coefficients of these variables, for example a by a dash and b by b dash are same, then definitely you can solve this equation by assuming this as some ratio and substituting the a and b in terms of a dash and b dash. Okay, is that clear? If you do this, then this equation which is non-homogeneous gets converted to variable separable form and you can work it out. Is that clear to all of you? Of course, I'm not giving the detailed procedure here because this is just a revision class and I have given enough explanation of this on the comprehensive course. So if you would like to visit, you can go for lecture number 2 of differential equations in comprehensive course. Okay, you will find each and every detail over there. Next, in case 2, let us discuss the case when a by a dash is not equal to b by b dash. Let us suppose there is some case like this where, of course, the ratio of these coefficients is not equal. Then you will make a substitution that x is equal to x plus h and y is equal to y plus k. In the equation, dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. So if you make this substitution, you will be getting something like d capital Y by d capital X, because if you differentiate this expression, d small y is equal to d capital Y plus 0, because this h comma k are constants. Okay, so if h comma k are constants, then it's obvious the differentiation of this y with respect to this capital Y is nothing but dy is equal to d capital Y plus 0. Correct? So this dy by dx term gets converted to d capital Y by d capital X, and this is equal to a times of x plus h plus b times of y plus k plus c divided by a dash of x plus h plus b dash of y plus k plus c dash. This is what you will be having. Did you all understand till this moment? Because we are substituting this small x as some capital X variable plus h and this small y as capital Y plus k. And for this particular substitution, can you all understand that this differential equation gets converted to this? Yes or no? Correct? Can you all understand this till this moment? Please respond. Please type in the chat box. Can you all understand till this moment? Yes? Now, if you can understand till this moment, then we can write d capital Y divided by d capital X is equal to, look, I am multiplying this a into capital X. Then I will be having ax plus by plus, there will be one term which is ah plus bk plus c divided by a dash x plus b dash y plus a dash h plus b dash k plus c dash. This is what you will be having. Correct? Now, when you have this equation like this, look, whenever you are substituting small x is equal to capital X plus h and small y is equal to capital Y plus k, this h comma k are your choices, correct? Because you are making some substitution. So it's your wish, whatever the values you can take for h and k. They are not restricted by some variable here, correct? Can you all understand this? The values of h comma k which are here are not restricted by any of the term in this given differential equation, correct? Can you all understand this? Which means whatever you want in place of h and k you can substitute. Correct? Or is there any h and k that are being governed by this equation? No. Correct? So now if you know this, since the choice of h comma k is in our hands, let us assume ah plus bk plus c is equal to 0 and a dash h plus b dash k plus c dash is equal to 0, which means I will choose my h comma k such that these two terms which are in bracketed here, a into h plus b into k plus c and a dash h plus b dash k plus c dash will be equal to 0. Okay, can I assume a set of values of h comma k such that for a given numerical values of a, b, c, a dash, b dash, c dash, can I get these two terms to be 0? Because I have two unknowns and two equations. These h and k are unknowns, So, and we have two equations. So can I calculate the values of h comma k which satisfies both these equations simultaneously? Yes or no? All of you please respond if you understand the things. Or if you have some difficulty, you please ask me. All of you please respond. Please type in the chat box. Can you all understand? We can choose a particular set of values of h comma k such that these two equations will become 0. Yes or no? If you can choose such values, then your equation dy by dx gets converted to ax plus by and divided by a dash x plus b dash y. Now, can I say that this first order differential equation is a homogeneous differential equation? Homogeneous differential equation? Yes or no? Correct? Now you can see this non-homogeneous equation, which is actually given by this particular differential equation. By making a proper choice of this h and k, we have converted into a homogeneous differential equation. Of course, in different variables, capital Y and capital X. Now, by putting capital Y is equal to some function of v into x, I mean capital X, and substituting dy by dx in terms of dv by dx and all, you can convert this equation into variable separable form again. Okay, I'm not continuing at this point, but if you put y is equal to vx substitution in this, and if you differentiate this, dy by dx is equal to something you will be getting. So if you put this here, your equation gets converted to variable separable form and you can solve the equation directly. Clear? I'm not solving because I didn't give you any values for this a, b, c and a dash, b dash, c dash. Okay, but I'm stopping this procedure here. For problems on this, since there are no gate problems that were asked on all these things in recent years after 2011 and all. But if you want some practice questions, you can always go for the comprehensive course where I have discussed enough number of questions on each and every case. Clear? Did you all understand this? Now, did you all understand how to convert a given non-homogeneous differential equation into homogeneous, and then after by substituting something to convert it into variable separable form? Did you all understand this? Yes or no? Please type in the chat box. Yes? So you have understood how to convert a given non-homogeneous differential equation to a homogeneous differential equation, and finally by putting one substitution, you can convert this homogeneous differential equation into variable separable form. Clear? I'm not dealing any sums here at this moment, but you can have enough number of questions on the comprehensive course, which I have already dealt. Okay, because there are no latest previous get questions on these non-homogeneous equations. Clear? So can I go for, shall we start solving questions? In yesterday's class, we were solving some first order differential equations. So shall we continue solving them? All of you, please respond. Can we continue solving them? Yes or no? Or do you have any doubt till this point? Please respond. If you have any doubts till this moment, you please ask me. I'll be happy to answer. Okay, so there are no doubts. Finally, we'll start solving. Okay. Of course, a very old question, 1995, computer science. So please try to answer this. If at every point of a certain curve, the slope of tangent is equal to minus 2x by y, then the curve is dash. Look, if I tell you this word, the slope of tangent equals something. What does the slope of tangent equal to? Suppose if you have any curve y is equal to f of x, can you tell me what could be the slope of the tangent of this curve? Can anyone of you tell me what could be the, if this curve is given by y is equal to f of x, then can you tell me what could be the slope of the tangent at any point? It's nothing but dy by dx, correct? Its derivative dy by dx, of course. So in the beginning class, I told you already, whoever didn't attend this basic calculus course, so please listen here. If you have any curve that's given here, if this is x and if this is y, and suppose if you have some random curve, something like this, then if you want the derivative at any point, for example, if you want the derivative at this point, then you can draw a tangent passing through this, maybe something like this, and if this is the angle theta, then tan theta is nothing but, if this point is x is equal to a, this, and if this curve is given by y is equal to f of x, then definitely f dash of a is nothing but tan theta. I have told you this, and I have given you what is the basic physical meaning of this derivative, correct? In my first lecture of basic calculus. So now if you see, the slope of the tangent means that is nothing but dy by dx at any point is equal to minus 2x by y. This is what it's given. So if this is the case, then what is this curve? That's the question. Okay, I hope you can solve this first order differential equation. It's a simple variable separable form. The only thing that you should know here is, if I am talking about slope of a tangent, means the slope of a tangent at any point. If I am talking about slope, that means I am talking about derivative of that particular function at a given point. Clear? I have already talked about this in my first lecture of basic calculus in revision course also. So is the answer ellipse? Okay, let me check. So if you shift this y here, y dy is equal to minus 2x dx. So this is in variable separable form directly. So if you integrate, y square by 2 is equal to minus x square plus constant. So this implies x square by 1 or c plus y square by 2c is equal to 1. And you can see this is of the standard form, x square by a square plus y square by b square is equal to 1. And of course, this term and this are not equal. So definitely this could represent an ellipse. Correct? Can you all recognize that this represents an ellipse? This equation represents an ellipse. In yesterday's class, I have shown you, if you can write this as root c whole square and this as root 2 c whole square, then definitely this is of the form x square by a square plus y square by b square is equal to 1. And where a is not equal to b, so definitely this is an ellipse. Suppose if there is a case that if a is equal to b, then we could have got a circle, because you know circle is a special case of ellipse when both semi-major axis length and semi-minor axis length are same. Correct? It's okay, Caligula. So please try to cope up with the things. So did you all understand that how ellipse is the answer for this particular question? Yes or no? Okay. Fine. Then this is second question. So please try to solve this. GATE 2004 civil engineering. It's a question from GATE 2004 civil engineering. So please try to solve this. Solution. So please try to solve this. Biotransformation of an organic compound having concentration X can be modeled using an ordinary differential equation, something dx by dt plus kx square is equal to 0. Good evening, Nani. So please try to continue. So dx by dt plus kx square should be equal to 0. This is the differential equation that's given. Of course, where k is the reaction rate constant. So which means k is a constant. That's fine. If x is equal to a at t is equal to 0, this is the condition that they have given at initial state. So initially when time t is equal to 0, there is some concentration of the organic compound x is equal to a, then the solution of the equation is dash. So please try to answer this. It's a very simple question. It's just an application of developing of a organic compound. So please try to solve this question. A differential equation is given to you, and of course it's a first order differential equation, and also some initial condition is also given to you, given that at time t is equal to 0, the concentration is x is equal to a. So please try to solve this equation using this boundary condition. Is it option B, Kamaluddin? Let's wait for others. See, all of you please try to solve these things, okay? Because differential equations is one such chapter in mathematics where you will be getting marks very easily, okay? There are no, big, very complicated things to solve over there. Option B, all of you are telling option B, okay, let me check. First of all, I can tell you one thing. Whenever time t is equal to 0, x should be equal to a. And whenever time t is equal to 0, all these options will give you x is equal to a, so that there is no use of checking options. So see here. Dx by dt is equal to minus kx square, correct? And I can write this as 1 by x square dx or minus 1 by x square dx is equal to k dt. And if you integrate this, this implies integration of minus 1 by x square is 1 by x, because differentiation of 1 by x is minus 1 by x square. So integration of minus 1 by x square could be 1 by x, and this is equal to k is a constant. So integration of dt will be t plus c. Now it's given at time t is equal to 0, the concentration is x is equal to a. Correct? At time t is equal to 0, it's given clearly that concentration is a. So in this equation, put t is equal to 0 and x is equal to a simultaneously. So if you do that, you will be getting 1 by a is equal to 0 plus c. So c is equal to 1 by a. And if you substitute c is equal to 1 by a in this equation, you will be getting 1 by x is equal to kt plus 1 by a, which is in option B. Okay, so simple. They have given you one differential equation of first order, of course, and also they have given you some initial condition so that you can find this the value of arbitrary constant. Clear? Fine. So I'm going ahead. Yeah, this is one thing. Gate 2006 somewhere. Okay. Now, next. A spherical naphthalene ball exposed to the atmosphere loses volume at a rate proportional to its instantaneous surface area due to evaporation. It's quite common for us. If you take some naphthalene and if you put it in atmosphere, what happens? It starts evaporating. Correct? So there is certain rate at which this evaporation is taking place. It's given a naphthalene ball is exposed to the atmosphere, loses its volume. Of course, since some mass is going out in form of vapors, definitely your volume gets reduced, and the decrease in volume at any instant is proportional to its instantaneous surface area. If the initial diameter of the ball is 2 centimeters and the diameter reduces to 1 centimeter after 3 months, then the ball completely evaporates in how many months? Please try to solve these questions. Okay, they are very good questions actually. Please try to solve this question. They have given you very clearly that this is some physics is happening. So try to model this physics into mathematics. And for modeling this physics of evaporation into mathematics, they have given you some mathematical conditions that it loses volume at a rate proportional to its instantaneous surface area. 6 months. Okay, let others do it. 6 months. Ankur, okay. Look, let us try to see. First of all, I have already told you in applications of integration, single variable integration, what is volume of a sphere? What is volume of sphere? If you have r as radius of a sphere, if you have small r as radius of sphere, can you tell me what's the volume of the sphere? Because ball can be approximated as a sphere, correct? And it's also given a spherical naphthalene ball. So the naphthalene ball is of some sphere to visualize. Correct? So if there is one ball, look, let me do it in the next page. So yeah, better. Let us suppose there is some naphthalene ball and the radius of this naphthalene ball is r at any given instant. Then can you tell me what is the volume of this naphthalene ball? Any one of you? Volume is equal to 4/3 pi r cube. Correct. And can you tell me something about surface area of this? Can you tell me something about surface area of this? We have talked how to find the surface areas, how to find volumes of all these curves, correct? And I told you volume of the sphere is 4/3 pi r cube, and also I told you surface area could be 4 pi r square. Now, if you read the question carefully, look what it's given. The spherical ball loses volume at a rate, means if you consider dv by dt, the rate at which this is losing the volume, since we are calling losing, we'll put a minus sign here, because as this time keep on increasing, this volume keep on decreasing, correct? So minus dv by dt is proportional to the instantaneous surface area. So what could be the instantaneous surface area at any instant? If r is the radius, then this is equal to surface area, which means can I write minus dv by dt is equal to some constant into as? Yes or no? Did you all understand? First of all, how did I write this equation? First of all, did you all understand how did I write this equation? And did you all understand why did I put a minus sign here? Because it's given the volume is being lost. So as time is increasing, this volume is decreasing. So since these two are counter effects, we put a minus sign here. Clear? Is that clear to all of you? Did you all understand why did we put a minus sign? Sir, how to identify linear and non-linear differential equations? We have discussed yesterday. Of course, we'll discuss today also. So don't worry. We'll discuss. Okay. So now, if you understand this, now see carefully. Minus d by dt of what is volume at any given instant? 4/3 pi r cube. And is equal to some constant into what is as? 4 pi r square. This is what you have. Now, You can cancel this 4 pi because this 4 pi is a constant, and this implies if you take out this 3, minus 1 by 3 into d by dt of r square is nothing but 3r square into dr by dt is equal to k times of r square. So if you see, this r square and this r square gets cancelled, and also this 3 and this 3 gets cancelled. So this implies dr by dt is equal to minus k. That means the radius is linearly varying with this, which means you can write r is equal to minus kt plus some arbitrary constant. So this is how the radius is varying with respect to time. Did you all understand how did I obtain solution for this particular differential equation? Are you all clear with this particular point? Did you all understand how come we got this differential equation here? And of course, if you get this, dr is equal to minus k dt. So when you integrate, r is nothing but minus kt plus c. Now, see the conditions to evaluate this k and c. It's given the initial diameter of the ball is 2 centimeters. What does this initial diameter mean? What is initial? At time t is equal to 0. Correct? So whenever time t is equal to 0, radius is equal to 2 centimeters. This is what it's given. Correct? Yeah. And the diameter reduces to, okay, the diameter is 2 centimeters, sorry. So radius could be 1 centimeter, of course. Correct? If diameter is 2 centimeters, then radius is 1 centimeter. Correct? And also the diameter reduces to 1 centimeter after 3 months. So whenever time is equal to 3, radius is equal to, actually the diameter got reduced to 1 centimeter, which means radius got reduced to half centimeter. Correct? So they want what is the time by which your r is equal to 0, means the ball completely evaporates. Look, in this equation you have two arbitrary constants, k, I mean we have two constants basically, k and c. So using these two equations which are given here, can you calculate what's the value of k and c? Yes or no? You have two unknowns in this equation and you also have two boundary conditions. So can you substitute this and can you tell me what are, the values of k and c and the exact relation of r in terms of t? Can you all tell me that? So please tell me what's the exact equation for r? K is minus 1 by 6 and r is, c is 1. Correct? Yes or no? Because if you put t is equal to 0, then 1 is equal to c, so c is equal to 1. And if you put c is equal to 1 and r is equal to 1 by 2, then definitely k should be 1 by 6. Minus 1 by 6. Correct? So this r is equal to minus 1 by 6t, so minus t by 6 plus 1. This is the exact relation between radius and time. So if you want to see, if you put radius is equal to 0, it's obvious you'll be getting time is equal to 6 months. So totally it takes 6 months for the ball to evaporate completely. Clear? Or is there any doubt in this question? See, these two conditions help you to get the values of these two constants. Okay, once you get these two constants, then this is how you can substitute. So for r is equal to 0, then 1 should be equal to t by 6 and t is equal to 6 from this. And since we are dealing t in months, of course it's obvious that in 6 months the ball gets evaporated completely. Did you all understand this? Did you all understand from the given question how did I form this basic differential equation? Minus dv by dt is proportional to as? Yes or no? Are you all understanding the things? Please respond if you are understanding the things. Or else if there is some difficulty, you please talk to me in the chat box. Any doubt to anyone at any point in this solution? Please, all of you type in the chat box because I couldn't see your faces. So please type in the chat box. Is it okay to all of you? I hope there is no doubt. Okay, got it? Good. So the answer is 6 months finally. Because for r is equal to 0, t is equal to 6. You know this. Next question. This is next question. Gate 2007, somewhere here. From the last equation, how we take 6? From which equation? In this equation. Sridevi, is this equation from which you are asking? Is this 6 you are asking about? Okay, let me solve for you. Okay. We have r is equal to minus kt plus c, and at t is equal to 0, r is equal to 1, t is equal to 3, r is equal to 1 by 2. Correct? So let us substitute this first equation or first condition in this equation. This implies r is equal to 1 when t is 0 plus c. So this means c is equal to 1. Correct? Similarly, now if you put this particular condition, then r 1 by 2 is equal to minus k t plus c, which is 1. So 1 by 2 minus 1 will give you minus 1 by 2 is equal to minus k into 3. So minus minus gets cancelled and k is equal to 1 by 6. Okay. So now if you get k is equal to 1 by 6, r is equal to minus kt. So minus 1 by 6 into t plus 1. And this can be written as r is equal to minus t by 6 plus 1. Okay. I hope now it's clear. You understood how we are getting this 6 here. Okay. And that's what exactly I have written here in a short notation before. R is equal to minus t by 6 plus 1. Okay, good. So please try to solve this question. It's a GATE 2007 question for mechanical engineering. So please try to answer. The solution of the differential equation dy by dx is equal to y square with initial value of y of 0 is equal to 1. So at x is equal to 0, we have the value of y as 1 and then bounded in the interval. I told you what is meant by bounded, correct? It should have a finite value, correct? So whenever you obtain a complete solution for this differential equation and that solution also satisfying this equation, then what could be the range? I mean, what could be the values of x such that the solution of this equation is completely bounded? So please try to answer this. And if you are liking the session, you please like the video and share it among your groups. And also if you are here for the first time, you please subscribe to the channel so that you'll be getting notified whenever we are launching some courses, so that you can follow them from the beginning itself. Okay. The solution of dy by dx is equal to y square. Okay, many of you are answering it C. Let me check. So if you convert this into variable separable form, 1 by y square dy is equal to dx. And if you integrate this, integration of 1 by y square is minus 1 by y is equal to x plus constant. This is the equation that is with us. Correct? So minus 1 by y is equal to x plus c. And it's given the boundary condition y of 0 is equal to 1. So if you put x is equal to 0 and y is equal to 1 simultaneously in this equation, this implies minus 1 by y is equal to 1 when x is equal to 0 plus c. So c is equal to minus 1. This is what you have. So if you try to write the complete differential equation, you have minus 1 by y is equal to x minus 1 and y is equal to 1 by 1 minus x. Correct? This is the complete solution of this particular differential equation, which also satisfies this boundary condition. Correct? Can you all understand that this y is equal to 1 by 1 minus x is the complete solution or the exact solution of this differential equation, which is also satisfying this condition? Yes or no? Please tell me. Did you all understand how did I obtain this equation? Of course, it's solving a simple differential equation which is in variable separable form. Now, if that's the case, now if you want this solution to be bounded, if this has to be bounded means, if for example, if this has to be a finite valued function, if this should be of finite value, then one thing should happen, this x minus 1 should not be equal to 0, which means x should not be equal to 1, correct? Because if you put x is equal to 1, this denominator goes to 0 and your total answer tends to something which is not finite. So if you see this 1, x is equal to 1 is present in all these three options, so we can't consider all these three options. And and you can see C is the only option where you don't have this 1. So except at 1, at every other value of x, this function goes to some finite value. Okay, so that's what the meaning of bounded we have already seen in applications of integrations. So I hope by this time you know what is meant by bounding of a particular function. Correct? Fine. So can I go for the next question? I hope all of you got it because many of you have answered it correctly. So fine. This is one question. GATE 2007 civil engineering again. So please try to solve this. This is something similar to that naphthalene bulb question. Okay. As time increases, temperature of a body decreases whenever it's cooling. It's given 60 degrees cools down to 40 degrees Celsius in 15 minutes when it's kept in air at a temperature of 25 degrees centigrade. What will be the temperature of the body at the end of 30 minutes? So please try to solve this. Yeah, Newton's law of cooling basically. I would like to give you what is Newton's law of cooling. So based on that, you please try to solve. Okay. Newton's law of cooling is given as dt by dt is equal to minus some constant into t minus t infinity. Okay. This is what the Newton's third law. I mean, sorry, Newton's law of cooling. Okay. Basically, this you'll be getting, if you are from mechanical a bit, you can understand conduction heat transfer will be minus Ka dt by dx, and this should be exactly equal to the heat lost due to convection, which is T minus T infinity. Okay. So now this A and gets cancelled, and dt by dx is equal to minus h by k, and for any given instances, this h is a constant and k is also a constant, so you can write dt by dx is equal to minus some constant into T minus T infinity. Okay. Where T infinity is the atmosphere condition. But of course, for solving this question mathematically, you don't need to know all those things. It's enough if you know that Newton's law of cooling is governed by this equation, and this T infinity is 25 degrees Celsius here. Okay. So dt by dt is equal to minus k times of T minus 25. This is the equation, differential equation that governs this cooling phenomena. Now it's given at T is equal to 0, 60 degrees, at T is equal to 15, 40 degrees. Then at T is equal to 30, what could be the temperature? That's the question. Okay. If you integrate this equation, you'll be getting two unknowns. One is K and one is plus C, arbitrary constant. So that's why you have at T is equal to 0, 60 degrees Celsius, and at T is equal to 15 minutes, we have 40 degrees Celsius. Okay, this is Newton's law of, this is the differential equation that governs Newton's law of cooling. Okay, and I hope if you are from mechanical, previously what explanation I have given here, that's how you write this Newton's law of cooling basically. Fine. Can anyone try to tell me the answer for this? No one. Please try and try to tell me the answer for this. I'll be waiting. Meanwhile, I'll be trying to write this equation. dt by d time is equal to minus k times of T minus 25. This is the differential equation that you have, and also T is equal to 0. We have temperature T is equal to 60 degrees Celsius, and T is equal to 15 minutes. We have T is equal to 45 degrees Celsius, and at T is equal to 30 minutes, what is the condition? That's what he is asking. Okay. So this is Newton's law of cooling, and basically this equation should be known to you. In my basic comprehensive course, I have already covered this. Whoever don't know about that, you can always take dt divided by dt is equal to minus some constant into T minus temperature of surroundings. This is given by Newton's law of cooling. Okay. In applications of first order differential equations, I have given you this. Okay. Do you all remember? I have given you this equation in applications of first order differential equations in my basic comprehensive course. Do you all remember this? Whoever have attended, they could remember this, I guess. We have talked about this equation in applications of first order differential equations in that course of basic comprehensive course of mathematics. Fine. So whenever you feel you are not able to catch up some things, definitely the explanation behind that point I would have given in comprehensive course. So you can please always refer to parallel videos in that course. Now this is the differential equation, and these are the boundary conditions. Can you solve? I mean, those are the initial conditions, and at a particular time t, 31.5 is the answer. Okay, something around 31.5. Yeah, B could be the answer. Let me check. So if you see this, dt divided by T minus 25 is equal to minus k dt. This is what you have. So if you integrate this, ln T minus 25 is equal to minus kt plus constant. This is what you have. So let us retain this equation. Now let us try to substitute these conditions. At time t is equal to 0, this t is equal to 60 degrees Celsius. So this implies ln 60 minus 25, which is 35, correct? So 60 minus 25 is 35 is equal to C. So C value is ln 35. Now, if C is ln 35, then what about K value? Let us try to substitute this condition again. At T is equal to 15, T is equal to 45. So this implies ln 20 is equal to minus K into 15 plus C, which is ln 35. This is what you get. So you can identify what is K. Now you know what is K and what is C, then you can calculate at T is equal to 30 minutes, what's the corresponding value of capital T. Okay. What's the value of K? Anyone of you could tell me? Could anyone of you tell me what's the value of K? Ln 35 by 20 is equal to 15 times of K. So K is equal to 1 by 15 of ln 35 by 20 is nothing but 7 by 4. Ln 7 by 4 divided by 15. 0.0564. Okay. So K is equal to something 0.0564 and C is equal to something around ln 35. So if you know these two quantities, you know the complete relation of T with respect to time. So you can substitute T is equal to 30. You will be getting something 31.5. Okay. So T is equal to 31.5 degrees Celsius. C is 3.5553. Okay. The value of this is 3.553. Okay. Cool. Did you all understand how to solve this question? We have what are the arbitrary constants are present or what are the constants that are given in the question? We could have solved them. And anyhow, if you want to solve them using virtual calculator, since I promised you, I will be solving them. Ln 35 is 35 ln 3.553, and if that's what is given, 3.553, and this is 1 by 15 ln 7 by 4. So 7 by 4 and ln of this ln 7 by 4 divided by 15. Oh, I think I have clicked divided by 25. So 7 by 4 ln divided by 15. 0.0373. I think you have given something different, right? 1 by 15 ln 7 by 4. Yeah, C is 3.553. I agree. Then what about K? 1 by 15 ln 7 by 4. Seven by 4 ln divided by 15. I think this should be the value of K, correct? K is equal to something 0.0373. 0.0373. Correct? Yeah. K is equal to 0.0373 is the value of K, and of course you can calculate this value at T is equal to 30 minutes now. Okay. I hope you can do this calculation, correct? Can I go for the next question? All of you please respond. Yeah, 0.0373 is the correct answer for value of K. Now if you put K is equal to this value and C is equal to this value in this equation, and at T is equal to 30 minutes, you can get what is T. Okay, 31.4 to something you can get, which you can approximate to 31.5 degrees Celsius. Okay, so can I go ahead for next question? All of you please respond. Can I go ahead for the next question? Are you all getting 31 point something around 31.5? Yes or no? Please respond. Are you all getting something around 31.5? Okay. Then this is the question. So please try to solve this. Get 2008 again. dy by dx is equal to minus x by y. At x is equal to 1 and y is equal to 3. I mean square root of 3. What is the differential equation corresponding to this question? So please try to solve this. They have given you some differential equation and they have also given you some condition for finding the arbitrary constant. So please try to solve this. At x is equal to 1, y is equal to root 3. 1 minus 3 minus 2. This could also satisfy, and this could also satisfy, and this could also satisfy. Okay. You can't check with options, Correct? Because in all options, when you put x is equal to 1 and y is equal to 3, all options are getting satisfied. Okay, some of you are telling D, some of you are telling it's B. Okay, let me check. What's the correct answer actually? Look, this implies y dy is equal to minus x dx. Correct? So if you integrate this, this is x square plus y square is equal to some arbitrary constant. Of course, you can write x square plus y square by 2 is equal to constant, which is also means x square plus y square is equal to constant. Let us try to put this. So if you put x is equal to 1 and y is equal to root 3 here, 1 plus root 3 whole square is equal to c. So c is equal to 4, which means the equation is x square plus y square is equal to 4. Look, in yesterday's class, I told you this arbitrary constant has to be simplified, correct? So x square plus y square is equal to c is same as x square plus y square is equal to 2c, because this constant here is arbitrary constant. Okay, you can take any value. So x square plus y square is equal to 4 is the actual correct answer. Which by solving till this moment also you can tell, because this is a constant and this constant doesn't involve any x or y in this, correct? So if this is only a constant, then definitely then the equation could look something like x square plus y square is equal to some constant which is only in this option D. So D should be the correct answer. Without even substituting this condition, you can tell that answer is D, because there is only one option which is involving x square plus y square is equal to something. Okay, I hope all of you did it correctly. So we are going for the next question. 2009 ME. Okay, before going for this question, I would like to teach you something again here. Look, before straight away going for that question, I would like to teach something for you. Look, can I write if dy by dx is equal to f of x comma y is the first order differential equation, then of course again telling you the detailed explanation of every topic is present in comprehensive course, but here I am just quickly revising the things. So see here, if I write dy by dx is equal to f of x comma y, can I write this function f of x comma y as some ratio of minus mx comma y divided by some other function of x comma y? Yes or no? Can I write it this way? This f of x comma y, which is a two variable function, can I write it as the ratio of two functions in this way? Yes or no? Please try to respond. Because if there is only x square or something like that, I can write this as divided by 1. Correct? Can I write this way? Which means, can I say that I can write this as dy by dx is equal to minus m of x comma y divided by n of x comma y, which means I can write m of x comma y dx plus n of x comma y dy is equal to 0. Can I say that this can also be the standard form of first order differential equation? Yes or no? Can I say that this equation is also the standard form of first order differential equation? Correct? Can I write it this way? Now, we have something called the exact differential equation. Exact differential equation. Now, what is exact differential equation? Look, suppose if you have any differential equation of this format where there is some function of x comma y into dx plus, again, see, this point is really important, so please listen. If you have any function or any differential equation in this format where you have a function in terms of x comma y into dx plus a function in terms of x comma y into dy is equal to 0, then for calling this differential equation to be exact differential equation, this m of x comma y dx plus n of x comma y dy should be equal to an exact derivative of some function involving x and y. Okay, this is called the exact differential equation if the left hand side of this equation is exact differentiation of some function. For example, if you see, if I have the function like x dy plus y dx, can I write this as nothing but derivative of xy? Yes or no? Can I write, if I have the differential equation x dy plus y dx is equal to 0, then can I write this particular term which is here as differentiation of x into y, which means this equation is exact differentiation of some function? Yes or no? So in general, if I have any functions m of x comma y and n of x comma y, of course dx plus dy and something, then if I want to say that this differential equation is exact differential equation, then this should happen. Correct? Now see carefully. Okay, will you all agree with me till this point? Can I continue? Please respond. Can I continue till from here? Now. Yes or no? Can I continue here? Fine. So see here. Now if you have this differential equation, now normally if you see differentiation of h of x comma y, if you have derivative of a function having two variables, can I write this as dou h by dou x into dx plus dou h by dou y into dy? Can I write it like this if I apply the chain rule of total differentiation? Yes or no? If this is h is a function of two variables x comma y, then the derivative of this function can be written as dou h by dou x into dx plus dou h by dou y into dy. This is called chain rule of partial differentiation, and you know this. So we have already covered this. So please, can we write it like this? Now, if this is equation 1, yeah, now if this is equation 1 and if this equation is equation 2, can you compare the things? If you compare these two equations, then this dou h by dou x should be equal to m of x comma y. Dou h by dou x should be equal to m of x comma y, and dou h by dou y should be equal to n of x comma y. Correct? Yes or no? Now try to see one thing. We have dou h by dou x is equal to m of x comma y, and dou h by dou y is equal to n times of x comma y. If you have this, now see carefully. Can I say whenever h is a function of both x and y, can I say that these two things are equal? Means if I differentiate the function first with respect to y and then with respect to x, or if I differentiate the function first with respect to x and then with respect to y, can I say that these two results are same? Yes or no? Yes, I can say this. Now, if I can say this, see carefully. If I differentiate this with respect to y, which is dou of, since this is nothing but dou by dou y of m of x comma y, of course. And if I differentiate this with respect to x, means dou h by dou y, this is dou by dou x of dou h by dou y, which is dou by dou x of n times of x comma y. Now, can you tell me that if I say both these left hand sides are equal, will you agree with me? As per that particular result that I have written on the right hand side, as per this result, can I say that the left hand side of both these equations are same? Yes or no? Yes or no? Please respond. Can I say from this particular from this set of equations that if these both left hand two side, if this left handed terms are equal, can I write dou m by dou x or dou m by dou y is equal to dou n by dou x? Can I write this? Yes or no? Can I write this? If I can write this, I can tell you one condition, the necessary and sufficient condition that the necessary and sufficient condition that the dE, the differential equation m dx plus n dy is equal to 0, where of course m is a function of x comma y and n is also a function of x comma y. So m is some function of x comma y and also n is also some other function of x comma y. So if these are two functions in terms of x comma y, is for this equation to be exact differential equation, the necessary condition is, can I write dou m by dou y is equal to dou n by dou x? Can I write this? Yes or no? Please tell me, which we have got just now here. Correct? Can I write this? Yes. And this question was asked not less than 4 times in GATE till now in different papers. Okay. They'll shift the options. They'll write dou m by dou x is equal to dou n by dou y. Then they'll write dou m by dou y is equal to minus dou n by dou x and all these things. But I'll tell you one thing to remember this. Yeah, Netflix. I think Sai Kumar, you remembered. So I think many of you know this word Netflix. So please remember this n and x. for this condition dou n by dou x here. Okay, so dou n by dou x. Remember this n and x with the help of this Netflix. Then it's obvious if you are writing n and x here, then it will be m and y here. Okay, so this condition is really important for this differential equation to be an exact differential equation. Clear? Is that okay to all of you? Okay. Now, sometimes there comes the differential equations such that I'll tell you how. Look, if you have x dy plus y dx is equal to 0, then it's obvious this is nothing but derivative of xy is equal to 0, and you say this is an exact differential equation. And also you can check, if you compare, this is n and this is m, because the equation is of the form m dx plus n dy is equal to 0. So if you check, dou m by dou y is equal to dou n by dou x, then dou m by dou y means dou by dou y of y is same as dou by dou x of n, which is x, and these values are 1. So both these values are 1. So you can tell this equation is an exact differential equation. But sometimes there comes differential equations such that the equations by themselves are not differentiable, I mean not exact derivatives. For example, if you see y dx minus x dy is equal to 0. Now, if you compare this equation, for example, with this m dx plus n dy form, if you are comparing this equation with m dx plus n dy is equal to 0, then your m value is y and n value is m dx plus n dy. So n value is minus x. Correct? This is what you have. If you take this as a differential equation, then this, if you compare with standard differential equation m dx plus n dy is equal to 0, then m value will be y and n value will be minus x. Correct? Can you all see this clearly? Yes or no? Now, can you tell me whether this differential equation is exact or not? This differential equation y dx minus x dy is equal to 0. Can you tell me that whether this equation is an exact differential equation or an inexact differential equation? Because by this time you know what's the meaning of exact and inexact differential equations. It's not exact, correct? Because if you check this condition, dou m by dou y is equal to 1, of course, and dou n by dou x is equal to minus 1. There is this minus sign here, and of course these two are not equal. But the condition that you need to have for the equation to be exact is this condition should get satisfied. But if you see here, this equation is inexact, correct? But now there is some term or some function called the integrating factor. Look, I would like to give the definition of this integrating factor. Integrating factor, the definition of integrating factor is the function which when multiplied to a non-exact dE, which when multiplied to a non-exact dE, non-exact differential equation, converts the dE to exact. Converts the dE to exact. Okay, this is what you have. So there is some function which when you multiply this function to a non-exact differential equation or inexact differential equation, this converts the complete function or the complete equation into exact differential equation. For example, see here. If you check this example, you have seen this y dx minus x dy is equal to 0 is not an exact derivative, correct? Because you have seen this. Now, if you see, I have taken y dx, correct? Y dx minus x dy. Okay. So y dx minus x dy is equal to 0. Now, if you multiply this complete function with 1 by y square, and of course 1 by y square on the right hand side also, that gives you 0. So if you multiply this complete function with 1 by y square, then if you check what could come, 1 by y dx is equal to, minus x by y square dy is equal to 0. This is the differential equation, correct? Now this is the differential equation which is obtained by multiplying this non-exact differential equation with this function 1 by y square, correct? Now if you compare this with standard differential equation, m dx plus n dy is equal to 0, then can you tell me something? M value is m dx, so m value is 1 by y, and n dy, so n value is minus x by y square. This is what you have, correct? So now if you check for the condition of exactness, then dou m by dou y is equal to differentiation of this term 1 by y with respect to y will give you minus 1 by y square, and dou n by dou x And whenever you are differentiating with respect to x partially, you will treat this minus 1 by y square as constant. So minus 1 by y square into differentiation of this x is 1. And you can see this dou m by dou y is equal to dou n by dou x. It is exact, which means whenever you are multiplying this factor 1 by y square to this non-exact differential equation, this 1 by y square is converting this non-exact differential equation into exact differential equation. Can you see this? Initially, whenever you set this exactness condition for this equation alone, your exactness condition failed, correct? Because here it is 1 and here it is minus 1. But now multiplying this inexact differential equation with 1 by y square, this 1 by y square when multiplied to this, this inexact differential equation got converted to exact differential equation. Can you all understand this much? Can you all understand this much till this point? Yes or no? Yes or no? Please respond. Yes. So if that's the case, we call this 1 by y square. Let me use a different color. So then we call this 1 by y square is the integrating factor. Integrating factor. Okay, this is what we call as an integrating factor. And if you see the definition of this, the function by which when multiplied to a non-exact differential equation, the function when multiplied to a non-exact differential equation converts the differential equation to exact differential equation. Did you all understand this, the meaning of this integrating factor? Now, how to find integrating factors? That's a different story. We'll see now how to find the integrating factors, because it's not easy always to see, to guess something like this. Okay, so we'll see some standard methods how to find the, basically some integrating factors for different cases. IF means integrating factor, Vignesh. Okay, so shall we continue? And of course, you can also see now this term y dx minus x dy by y square is nothing but derivative of x by y, correct? If you write the derivative of this, y dx minus x dy divided by y square, and if you see the left hand side of this equation is exactly the same thing. It's an exact derivative of some function x in terms of x and y. Okay, so this is how you can see. Now let us try to see how to find the integrating factors. If m dx plus n dy is equal to 0, means it's a first order differential equation, is a homogeneous differential equation, of course this is the first order, so homogeneous differential equation. Then can you tell me what is the integrating factor? I have covered in my comprehensive course already. If m dx plus n dy is equal to 0 is a homogeneous function, then is a homogeneous differential equation, then can you tell me what is the integrating factor? 1 by, can you tell me what is the integrating factor? 1 by anything. Can you tell me something? 1 by any one of you. 1 by mx plus ny, correct. 1 by mx plus ny is the differential. No, it's not mx plus ny, it's 1 by mx plus ny. Okay, please don't write mx plus ny, your answer will be wrong. Integrating factor will be 1 by mx plus ny. Okay, for example, you have seen y dx minus x dy is equal to 0, and if you see this is y by x is equal to dy by dx. Now this is a homogeneous differential equation because these two are homogeneous functions of degree 1. So this y by x is totally a homogeneous function of degree 0. So if you want to calculate the integrating factor, 1 by 2xy could also work out as an integrating factor for this. Look, for a given differential equation, there can be many integrating factors. There is no case that the integrating factor will be unique. There can be many integrating factors depending upon the situations, but this is how one standard way you can, write always. Then if you compare, this is m and this minus n is n, m dx plus n dy is equal to 0. So if you apply this 1 by mx plus ny, n is minus x and this is y. Since you are getting 1 by 0 from here, we don't use this, but of course we go for 1 by y square here. Okay. Anyhow, if this is a homogeneous function, of course this is an exception case. So normally if you see, we have some rules for finding integrating factors. This is how we write it. Please tell me the best reference textbook for engineering mathematics. As I told you, Sai Babu, you can always go for engineering mathematics by B.S. Gravel, and also you can go for some other thing like advanced engineering mathematics by this Evan Kreyszig, and you can always go for one more book which is for if you want to practice few problems, then you can always go for this thing which you call B.V. Ramana. This is one good book where you can get many number of problems of gate standard and all. Okay, so these are some standard differences that you could always go for. Okay, I hope this is the case. You can go for any of these three books, and also this book, Engineering Mathematics by B.S. Gravel, is quite standard book that many universities across India follow. Not only in India, across many other places. And this Advanced Engineering Mathematics is a really fantastic book for applied mathematics exclusively. Okay, so if you're having some physics that's governed by some mathematical equations, then this book is a really good book for that. Fine. Fine. So see here. Next, there will be some functions where you have y into some function in terms of xy into dx plus x into some other function in terms of xy into dy is equal to 0. Then integrating factor if is equal to 1 by mx minus ny. Okay. Similarly, if 1 by n into dou m by dou y minus dou n by dou x is f of x. If some function of x, then e power integral f of x dx is the integrating factor. Okay. So these are basically the ways how you can calculate integrating factor for any given differential equation at any instant. Okay. And of course, I have mentioned all these formulas also in my comprehensive course, so you can go there if you would like to see. Okay. So now we'll try to solve this question. Before solving that question, I would like to give you one thing which is called the linear, or you can say maybe the Leibniz linear equation. Leibniz linear equation. And this equation is of the form, it's a first order differential equation, of course. So since we are dealing only first order differential equations today, so this linear Leibniz equation or Leibniz linear equation is a first order differential equation which is of the form dy by dx plus p times of y is equal to q, where p comma q are functions of x alone. So where p comma q are functions of x alone. Okay. So they are only functions of x. So how to solve this equation? First of all, you need to find the integrating factor if is equal to e power integral p dx. So once you get what is an integrating factor, because if this p is only a function of x, you know how to evaluate this integration of some function of x dx. You know how to evaluate this, so you will be getting what is this function. So once you get this function, solution is look how the solution could look like: y into e power integral p dx, which is the integrating factor actually, is equal to integral q into integral e power integral p dx to this whole dx plus constant, where c is some arbitrary constant. Okay, so this is the solution of this particular differential equation. Of course, in my basic comprehensive course, I have derived this equation, how this equation and this solution came here. But now I'm not doing it because of time constraint, because we have many more problems to finish today. So, but this is how you will be writing the solution of any linear Leibniz equation which is of this particular format. Okay, is that clear to all of you? And this is how you will be finding integrating factor for this case: e power integral p dx. Okay. And one more thing I forgot to tell you actually, if you have, let me tell this point somewhere here. Yeah, we talked about exact differential equations at this moment. Yeah, here. So if m dx plus n dy is equal to 0 is an exact differential equation, then the solution of the differential equation is given by, directly you can write, then the solution of differential equation is integral m dx treating y as constant, so whenever you are treating y as constant, you will have only one variable, which is x. So integration of this m, which is a function of both x comma y, but since you are treating y as a constant, this will be a single function. I mean, this will be a function of single variable, so you will integrate that, plus integration terms not containing x in n dy is equal to constant. Okay, now if you see, this is an equation. Of course, if you integrate this, you will be getting some function of x and y. I mean, you will be getting some function in terms of x and y, and definitely this second integration, which is here, will contain only the terms of y, because we are neglecting the terms which are containing x. So these terms will contain only y, and whenever you are integrating with respect to y, again this complete integral will give you just terms of y. So this is the solution here. Okay. So this is the solution whenever you have an exact differential equation. So you can directly write the solution without going for any of the methods like variable, separable, or basically solving non-homogeneous system of equations and all. Clear? For example, if you want to check one thing, look, 2x plus 2y plus 4, I mean 3 something, dx plus this is m, dou m by dou y, so this is 2 should be equal to dou n by dou x. So 2x plus y minus 4 dy is equal to 0. Now if this is differential equation, normally if you check, we will be getting dy by dx is equal to minus of 2x plus 2y plus 3 divided by 2x plus y minus 4, correct? Now if you see, normally this is a non-homogeneous differential equation, and also it's a special case where the ratio of the coefficients is not same, correct? Can you all understand this? This is a non-homogeneous equation, and of course the ratio of coefficients is not same here, means this a by a dash and b by b dash are not same. Can you understand this, that this is a non-homogeneous differential equation with variable ratio of coefficients? Yes or no? Now if you want to solve this, actually, as I told you, you should take x is equal to x plus h, y is equal to y plus k and all, and you need to do this. But since this is an exact differential equation, you can do one thing. Look, if this is n, see, if you take this as m and if you take this as n, then it's of the form m dx plus n dy is equal to 0, and you can see dou m by dou y, which is 2, is also same as dou n by dou x, which is also 2, and if you see, these two are equal, so it's an exact differential equation. So normally by substituting x is equal to x plus h, then y is equal to y plus k, and then if you solve this equation, you will be getting some solution definitely, and that solution will be same as integral m dx. So 2x plus 2y plus 3 dx, taking y as constant plus integral terms not containing x in n, which is y minus 4 dy is equal to constant. So if you integrate this, integration of 2x is x square, plus if you treat this 2y as a constant, this is 2yx plus 3x, plus integration of this is y square by 2 minus 4y is equal to constant. This will be the solution of that particular equation, and this will be the same solution which you obtain when you substitute this. Then find the values of h comma k, make the equation homogeneous, then substitute capital Y is equal to V into capital X, and then if you do all these things, do you all remember the standard procedure that I told you to solve a non-homogeneous differential equation with variable ratio of coefficients? Yes or no? Did you all remember the standard procedure that I told you for finding the solution of this non-homogeneous differential equation? Yes or no? By taking small x is equal to capital X plus h, small y is equal to capital Y plus k and all. Now after doing all these procedures, whatever the solution you will be getting, that solution will be same as this solution. Okay, so that's why this formulation is really important whenever this DE is an exact DE. Clear to all of you? Did you understand what's the use of this formula here? If you know this formula, then definitely your procedure for non-homogeneous equations gets reduced by a lot. Okay, so now if you have a Leibniz linear equation, if you have a Leibniz linear equation of this form where you have some function in terms of x and some function in terms of x again, then this is the integrating factor and this is the solution of the differential equation. Now with the help of this, let us try to solve a question that came in 2009 for mechanical. So please try to solve this. Solution. Given differential equation is x into dy by dx plus y is equal to x power 4, and it's also given y of 1 is equal to 6 by 5. So please try to write this. Yeah, of course I didn't upload previous 2 lectures. Today I'll be uploading. Okay, because of some issue we couldn't upload yesterday, so today I'll be uploading. Okay, I'll upload all the 3 lectures today. Basic, cumulative session 2 and first lecture of differential equations and today's class. Okay, and whoever is new here for the first time, we will be uploading the notes of every class in the Telegram channel, for which you are getting the links in the chat box. Okay. Out of all these options, can you tell me which option cannot be the answer definitely? Out of all these options, can you tell me which option cannot be the answer? Can you please tell me, out of all these 4 options, which option cannot be the answer for this question? Option D, Divya, is it? But actually this B cannot be the answer, because this y of 1 is equal to 6 by 5 is given here, and if you put x is equal to 1, this value of y is 8 by 5. Okay, it's not 6 by 5. So this is wrong answer for sure. Now please try to tell me what's the answer for this. Any one of you, please try to tell the answer for this. Option A, is it x power 4 by 5 plus 1 by x? If is equal to x, what is if is equal to x? Sai Babu, look, I'll solve for you. So please see here, if you divide this complete equation with x, we have 1 by x, y is equal to x cube. Yes or no? Can we have this equation if you divide this equation completely with x? Yes or no? Now, is this equation is of the form linear Leibniz equation, because this is a function of x and this is also a function of x. So this is something Leibniz linear equation form. So integrating factor if is equal to e power integral p of x, which is 1 by x dx. See here, if is equal to e power integral 1 by x dx, and you know this is equal to e power integration of 1 by x dx is ln x. And I told you in yesterday's class, e power log x to the base e is same as x. Okay, if means integrating factor. Okay, I got it. Sorry. So if integrating factor is x, then the solution is y into integrating factor is equal to integration of this function q here, which is x cube after the conversion. So x cube into again integrating factor plus constant. So this is x power 4. So if you simplify the things, we have y into x is equal to integration of x power 4 is nothing but x power 5 by 5 plus constant, and this implies y is equal to x power 4 by 5 plus c by x. So y is equal to x power 4 by 5 plus c by x. This is what it's given, and also it's given y of 1 is equal to 6 by 5. So if you put x is equal to 1 and y is equal to 6 by 5 simultaneously in this equation, you will get the value of c. Let us try to put it. Y is 6 by 5 and this is 6 by 5 when x is equal to 1. So 1 power 4 divided by 5 plus c by 1. So this implies c is equal to 1. So y is equal to x power 4 by 5 plus, since c is 1, this 1 by x is the solution for this. X power 4 by 5 plus 1 by x, which you can see in option A here. Okay, option A is the correct answer. Look, you should never consider x power 4, okay, because this is differential equation but not in linear Leibniz form. Now by dividing with x, we got this as the linear Leibniz form. Okay, so you should take this as q, not this. Clear? If you take this x power 4 as q, your answer will change. So you need to be careful a bit. Did you all understand how this can be option A but not D? See, whenever you are taking q, you should take this x cube because this is the equation which is in Leibniz linear form. Okay, but this equation is not a Leibniz linear equation, so we can't take this as q and apply this integration here. Did you all understand? Whoever got D, I think this is the mistake you have committed. Yes, did you all understand this? Why we are getting option A as the answer for this question? If you have any doubt, you can ask me, or else that's fine. A is the correct answer. Okay, that's why you need to be careful. Out of these two forms, the bottom equation is the Leibniz linear equation form. So whatever you apply in this formulation, you should apply for this particular differential equation. dy by dx plus 1 by x into y is equal to x cube. Okay, I'll repeat. So see here. Normally, you have the equation as x into dy by dx plus y is equal to x power 5, correct? But I told you that linear Leibniz equation is of the form dy by dx plus some function of x into y is equal to some other function of q. So first of all, to solve this equation, let us convert this equation to Leibniz linear equation. So if you divide this complete equation with x, you will be getting dy by dx plus 1 by x into y is equal to x power 5 by x, which is x power 4. This is what you have as a Leibniz linear differential equation. Now take p is equal to 1 by x and q is equal to x power 4. Okay, you will be getting the answer. Integrating factor if is equal to e power integral 1 by x dx, and which is in power log x to the base e, and which is x. So if integrating factor is x, then y into x is equal to integration of q is x power 4. So x power 4 into integrating factor is again x dx plus constant. Now did you understand how did this come? Got it. Okay, good. I'm going for the next question. So please try to solve this question. Oh, match each differential equation in group 1 to its family of solution curves from group 2. Okay, so group 1 is the differential equation that's given here, and group 2 is something, family of curves which represent the solution of this. So please try to solve this question. Meanwhile, I'll be having some water. So please try to solve this and tell me the correct answer. So now I hope you can see the question. So please try to solve. It's a really good question. Of course, it was asked in 2009, but still it's a really good question. So please try to answer. To answer this, option A, Mauli, Kamaluddin, Krishna. Okay, so let me check. Let me check the first option. Let us check what is the corresponding family of curve for A. dy by dx is equal to y by x. Okay, which means can I write 1 by y dy is equal to 1 by x dx? Which means if you integrate this, you have ln y is equal to ln x plus constant. So this is equal to ln of y by x is equal to constant, which means y by x is equal to e power constant, which is again a constant. So y is equal to some constant into x. This is what you have as the family of curves for the first equation. So which means y is equal to some constant into x is a straight line equation. Y is equal to mx form. So this maps for 2, which means these B and D are not answers because for A they have only 2. Next, let us check for B. If you check for B and if you get 3 as solution, then first option is the answer. If you get 1 as the solution, then Third option is the answer. Correct? So let us check for that also. B is dy by dx is equal to minus y by x. Okay. So minus 1 by y dy is equal to 1 by x dx. This is what you have. So if you integrate ln y, of course minus sign, minus ln y is equal to ln x plus constant. So this implies xy is equal to constant is the solution. Correct? And you know xy is equal to constant is nothing but a rectangular hyperbola. And you can see this B goes for 3, which is only present here but not here. So A is the correct answer. Similarly, if you want, you can check for C and D also. Okay. Do you all understand why this is a rectangular hyperbola? You know, xy is equal to constant means nothing but 0, x, y, minus x and minus y. If xy is equal to constant, that represents something like this. Okay. Of course, since there are families of hyperbolas, you can have many number of hyperbolas like this. Similarly here and also here. Okay. Is there any difficulty with this question? It's very simple. When you solve the first differential equation, you will be getting the solution like y is equal to mx form, which means you know this first equation is going for straight lines. Similarly, when you solve the second equation, you got some equation of rectangular hyperbolas, so which is 2 maps for 3. Similarly, if you solve for C and D, you will get 3 and 1 again. Since these two are enough to analyze, we have stopped my discussion here. Is it clear to all of you? Can I go for the next question? Please tell me, did you all understand how it's option A for this question? Or is there any doubt at any point? Please ask me if you have some doubt. I need responses from all of you. Did you all understand this? Okay. Fine. This is GATE 2010 instrumentation. So please try to solve this. Please try to solve this. Consider the differential equation dy by dx plus y is equal to e power x with y of 0 is equal to 1, then the value of y of 1. Please try to solve this question. It's a very easy question. So please try to solve this and tell me the answer. And meanwhile, if you're liking the content, please like the videos that are being shared on this channel. Okay. Option C. Is it option C? All of you, please try to respond. Is it option C, y of 1 value? Look, the differential equation is dy by dx plus y is equal to e power x. Can I write this as 1 into y? Yes or no? Can I write this as 1 into y? Now, this 1 can be written as x power 0. So, this is a standard Leibniz linear equation form. So, integrating factor if is equal to e power integral 1 dx, which is e power x is the integrating factor. So, solution is y into e power x is equal to integration of this term on the right hand side is e power x, and also this integrating factor is also e power x. So, e power x whole square, which is e power 2x dx plus constant. So, y into e power x is equal to e power 2x divided by 2 plus constant. Now, it's given y of 0 is equal to 1, means when x is equal to 0, y value is 1. So, if you put x is equal to 0 and y is equal to 1 simultaneously here, you will get c as 1 by 2. So, this implies c is equal to 1 by 2. When you put x is equal to 0 and y is equal to 1 simultaneously in these equations, correct? Because 1 is equal to 1 by 2 plus c. So, c should be 1 by 2. If c is 1 by 2, then the solution is y into e power x is equal to e power 2x by 2 or e power 2x plus 1 divided by 2. Now they are asking you y of 1. So this implies y into e is equal to 1 plus e square divided by 2. So y is nothing but 1 by 2 of e plus e inverse. Correct? I think option C is correct. Y value from this equation is 1 by 2 of E plus E inverse. Because if you see, if you take this 1 by 2 common, 1 plus E square divided by E is what you will be having for Y. Of course, this is not equal to. Y is equal to 1 by 2 into 1 by E plus E square by E. So this is nothing but 1 by 2 into E plus E inverse. 1 by E is E inverse plus E square by E will be 1 E. So E plus E inverse is the correct answer. Of course, multiplied with a 1 by 2. Is there any difficulty in this question? All these are simple questions. As I told you, in differential equations, generally you will be getting simple questions to answer. Okay. But of course, that's a very, very important topic for engineering applications. So you need to learn them. So can I go for the next question? Please tell me. Can I go for the next question here? Okay. This is the question. 2011 Triple. This is a solution. So please try to solve this. It's again a first order differential equation. Dy by dx is equal to e power minus 3x. I think the answer should be A, correct? Because it's directly given. It's a variable separable equation. So dy by dx is equal to e power minus 3x. So this implies dy is equal to e power minus 3x dx. So if you integrate this, y is equal to integration of e power minus 3x is e power minus 3x divided by minus 3 plus constant. And that's exactly given in option A. Okay, this is very simple question to answer. But of course, it's a previous gate question. As you can see, it was asked in 2011. Okay. Yeah, I hope there is nothing much explanation needed for this. So I'm going straight away for the next question. Gate 2012 civil engineering again. So please try to solve this. Dy by dx plus 2y is equal to 0. Is equal to minus 2y. Otherwise, you can write 1 by y dy is equal to minus 2 dx, which means ln y is equal to minus 2x plus constant. So y is equal to some constant into e power minus 2x. This is the solution. So for getting the value of c, they have given this condition. Y is equal to 5 and x is equal to 1. So y is equal to 5 e square is some constant. So 5 e square into e power minus 2x. 5 e square into e power minus 2x is the value. So they have given you the value of 5 into e square. Let us calculate that. So e square into 5, 36.94, 36.95. Okay, D is the correct answer. These are simple questions, correct? I think no need of much explanations at this point. Everyone of you could do this. Any doubts to anyone? How I am writing this plus c as into c and all? D is the correct answer. Yes? Shall we go for the next question? Because this is a very easy question to answer and I think there is nothing difficulty in this. Okay. Again, this is one such question. So please try to answer. Gate 2014 mechanical. The solution of the initial value problem, dy by dx is equal to minus 2xy. So please try to answer this. Dy by dx is equal to minus 2xy. So please try to answer this question and try to tell me the answer. Y of 0 is also given as 2. Means when x is equal to 0, y value is 2. This time I don't solve this. You please try to solve this and tell me the answer for this. All of you, please try this question. It's a simple question really. But of course, all these are previous gate questions. Okay. As I told, in differential equations, we are having very easy questions, fortunately. So B is the correct answer. Is it? Okay. So let me check. Let me wait for others as well. Can we use Leibniz method? Yeah, you can use. You can use Leibniz method. Y of 0 is equal to 2. I think all options are satisfying that condition, correct? Anyhow, B is the correct answer. So, yeah, Dinesh, you can use Leibniz method, but first of all, let me use variable separable method and try to solve this. Is equal to minus 2x. Sorry, this should be dy is equal to minus 2x dx. So, if you integrate this, you will be getting ln y is equal to minus x square plus constant. So, y is nothing but constant times of e power minus x square. Now it's given y of 0 is equal to 2. So when x is equal to 0, y is equal to 2. So c value is 2. So y is equal to 2 times of e power minus x square. Option B. Similarly, if you solve it using Leibniz method, your equation looks something like this: dy by dx plus 2x y is equal to 0. So q is equal to 0. Directly integrating factor I of is equal to e power integral 2x dx, which is e power x square is the integrating factor. So solution is y into integrating factor is equal to 0 plus constant. So y is equal to c into e power minus x square. And if you see this solution and this solution, both are same. Okay. Now for finding the value of c, you need to substitute boundary condition anyhow, or the initial value conditions. Correct? Can you see that both these solutions are analogous and same? Y is equal to constant into e power minus x square, and that also, if you use Leibniz equation, even that could be fine. So I am going for the next question. So please try to solve this. This is one good question. So please try to solve this, all of you. The figure shows the plot of y as a function of x. The function shown is the solution of the differential equation. Okay. Please try to solve this. This graph shown here is solution of one of these differential equations which are given in options. So please try to solve this. I hope you can see the graph clearly. There is origin, and then y is equal to x square by 2 onto the top, and y is equal to minus x square by 2 onto the bottom. So please try to solve this. Option D. Is it? Look, can I write y is equal to x square by 2 when x greater than 0, or maybe equal to 0 also, minus x square by 2 when x is less than 0. Can I write this from this graph? Because you have seen, if this is the point 0 comma 0, to the right of this point, the equation of curve is y is equal to x square by 2, y is equal to x square by 2, and similarly in the denominator, this is, in the negative axis of y, this is minus x square by 2. So if you differentiate this, dy by dx is equal to, differentiation of this x square by 2 is x when x greater than or equal to 0, and differentiation of this is minus x when x is less than 0, and this is nothing but mod x. Okay. In the beginning of basic calculus, I have given you mod x is nothing but x when x greater than or equal to 0, and minus x when x is less than 0. This is what exactly you got here. So dy by dx is equal to mod x, which is in option D. So I hope you got the answer for this. Okay. There is nothing big difficulty in this. Just you need to verify out the differentiations. Can I go for the next question? Did you all understand this? There is nothing difficulty in this actually. 2015 ECE. So please try to solve this. 2015 ECE. Electronics basically. So please try to solve this. The general solution of the differential equation dy by dx is equal to 1 plus cos 2y divided by 1 minus cos 2x. So please try to answer this question. 1 plus cos 2y divided by 1 minus cos 2x. Option D, BVR. There should be one tan y. Okay. Answer should be one of A and C, I guess. Yeah, C could be something calc because definitely it should involve tan y in the answer as far as my knowledge is concerned. Yeah. Okay, that was for previous problem. Okay, good. So C is the correct answer for this. Is it? So previously when I am discussing this basic calculus, some of you have asked me for basic formulas of trigonometry. You remember? And then I gave you cos 2x is nothing but 2 cos square x minus 1, or this can also be written as 1 minus 2 sin square x. Do you remember this? I have told you these formulas. So if you see, this dy by dx can be written as 1 plus cos 2y. So if you shift this 1 plus cos 2y can be written as 2 cos square y, and this is written as 2 sin square x. So 2 gets cancelled. So this cos square y, if you bring on to the left hand side, this is nothing but 1 by cos square y, so which is secant square y dy is equal to this sin square, 1 by sin square can be written as cosecant square x dx. Now this is completely a function of y on the left hand side, and this is completely a function of x on the right hand side. So this implies integration of secant square y is tan y is equal to integration of cosecant square x is, differentiation of cot x is minus cosecant square x. So integration of cosecant square x is minus cot x plus constant. So this implies tan y plus cot c is equal to some constant, which is in option C. Okay, yeah, correct. C is the correct answer for this. See, all these are simple questions, but they are all previous gate questions. Okay. Is there any difficulty to anyone in this question? Did you all understand this? You need to be careful with plus and minus signs here. Okay. If you write this as cot x, then your answer changes. Tan y minus cot x is equal to constant. You will be opting for first option. Okay. But that is actually wrong. So C is the correct answer for this. And what's the time, by the way? We are continuously discussing the problems. 10:42. Okay. So please try to tell me the answer of next question. This is next question, I guess. Yeah. This is next question. Yeah. Okay. Fine. Gate 2015 EC again. So please try to solve this. Consider the differential equation dx by dt is equal to 10 minus 0.2x. The response x of t for t greater than 0 is dash. So please try to solve this question. They have given you one condition that dx by dt is equal to 10 minus 0.2 times of x. Okay. 10 minus 0.2 times of x with initial condition x of 0 is equal to 1. So x of 0 is equal to 1 is also the initial condition. Now please try to solve this for t greater than 0. There are two methods in which you can solve this question. You can convert it into variable separables, or you can convert this question into Leibniz linear equation and you can solve. Okay. So I'll be waiting for your answers. So please try and tell me the answer for this question. All of you, please try to solve this question and tell me the answer. The differential equation is dx by dt is equal to 10 minus 0.2 times of x with initial condition x of 0 is equal to 1. So please try to solve this and tell me what could be the answer. Side, sir. Okay. Fine. You can solve now. Option D, Kamaluddin. I think this should be this 2t minus should be somewhere here. Okay. E power minus 0.2t. because in all options we have e power minus 0.2t. C is the correct answer. Then D. Okay, let me try to solve this. See here. So this implies dx by dt plus 0.2 times of x is equal to 10. Okay, if this is the case, then you can get the integrating factor if is equal to e power integral 0.2 t dt, and which is e power, this is the function dx by dt plus 0.2 into x is equal to 10. So yeah, this 0.2 is the function of t. So e power integral this t, I think this t should not come here again. So 0.2 dt. Okay. So 0.2 dt, which means you have e power 0.2 into t as the integrating factor. If this is the integrating factor, then definitely the solution is y into e power 0.2 t is equal to integration of 10 into integrating factor e power 0.2 t plus constant. So y is equal to 10 by 0.2 correct plus c into e power minus 0.2 t. This is what you have, and of course this is 50. So y is equal to 50 plus some constant into e power minus 0.2 into t. This is the solution for getting the value of c. I think they have given you one condition. What is this condition? X of 0 is equal to 1. So at t is equal to 0, x is equal to 1. So let us try to put t is equal to 0 and x is equal to 1 at a time. Yeah, correct. These are x. I'm sorry. This is x. X into this implies x is equal to, this implies x is equal to. Okay. So now this implies when you substitute 1 is equal to 50 plus c into, when you put t is equal to 0, this value is 1. So c is equal to minus 49. So the solution for this is 50 minus 49 into e power minus 0.2 into t. Is this option present in any of the cases? 50 minus 49 into e power minus 0.02 t. This is the correct answer. So that integration explain. Which integration, Shabin? This integration? Shabin, which integration you want me to explain again? Please tell me, is this integration? Or maybe this integration? Last integration. So this integration. So see here. Integral 10 into e power 0.2. Of course, there is one dt here plus constant. So 10 into e power 0.2 t dt. This is what you have. This 10 is a constant. So 10 into integration of e power 0.2 t is e power 0.2 t divided by the inner derivative of this function, which is 0.2. Okay. So this is how we have, which I have written something like this here. And then cancelling e power 0.2 t everywhere, you will be getting e power minus 0.2 t here. Okay. I hope you can understand this. This is a direct step. Actually, your solution could look something like x into e power 0.2 t is equal to 0.2, and this 10 cancels 50 times. So 50 into e power 0.2 t plus c. This is how your solution look like actually. Okay. So if you cancel this e power 0.2 t at all terms, you will be getting 1 e power minus 0.2 t here. Yeah. Okay. So this is one question of civil engineering GATE 2017. So please try to solve this. So please try to solve this. The solution of the equation dq by dt plus q is equal to 1, and we have q is equal to 0 at t is equal to 0. So please try to solve this question. This is not the answer for sure. So please try to answer this question. It's a very simple question. So Leibniz linear form, integrating factor is equal to e power integral 1 dt, so which is e power t, and the solution is q into e power t is equal to integration of 1 into integration of e power t is again e power t plus dt, I mean plus constant. So if you see, q is equal to 1 plus c into e power minus t, and of course when t is equal to 0, q is also 0. When t is equal to 0, so c plus 1 is equal to 0, so c is equal to minus 1. So q is equal to 1 minus e power minus t is the answer. Option D. If negative sign was there, should we take that along with constant as integrating factor? Yeah, suppose if there is negative sign here, then definitely you need to take this negative sign. Okay, for example, if the equation is dy by dx minus xy is equal to something, then whenever you are taking integrating factor, your integrating factor should be equal to e power integral this minus x dx. Okay, because whenever you are defining standard Leibniz linear Leibniz equation, you have taken the form of dy by dx plus some function of x into y is equal to some other function of x. Correct? So whenever there is a negative sign here, you need to take that negative sign here in integrating factor. I hope, Shavin, that's your doubt. Correct? Anyhow, so I think we have few more questions to do with, but I think we're going to stop here since it's more than 10:50 right now. Yeah, 10:51. So any questions that you would like to ask me on division lecture number? No. In comprehensive course and division lectures, no, it's not same, because basic calculus here I have taken 14 lectures, I think, including single variable and multivariable. But in comprehensive course, we have only 10 lectures of basic calculus. Similarly, differential equations, I have taken 7 lectures in comprehensive course, but now hardly 4 lectures could be sufficient, because you have seen many of the questions are repetitive in nature. Correct? Only linear Leibniz equation or first order differential equations and all. So it's not useful for us if you keep on doing the same kind of problems. So I have shortened some problems and we'll move on to next chapters. And the next chapter that we'll deal after this, differential calculus is vector calculus. So e power t come in the equation. Why it is non-homogeneous? Sorry, I didn't understand your question. Where is this e power t? Shabin, I didn't understand. E power t come in the equation where? Why it is non-homogeneous? No, I think Kamluddin, he is not asking about linearity, but he's asking something about homogeneity. Look, in homogeneous equations, I told you clearly, for dy by dx is equal to some function of this, you can call this equation as homogeneous only if this is a homogeneous function of degree 0. Homogeneous function of degree 0. Okay, only in that case we can call this as homogeneous differential equation. But this e power t has some expansion series, as Kamaluddin told, that you can't take any kx or ky common out here. How to watch comprehensive lecture so that I can connect with revision simultaneously, sir. The link for the comprehensive course is in the description box of this video. If you click show more, you will be getting link for comprehensive course. Definitely you can click that link, you'll get all the lectures. Or else, if you don't find that, even you can always see the playlist of comprehensive course in the same channel somewhere. dy by dx plus e power t in yesterday's class. Dy by dx and e power t, is it? But if there is x here, how it could come t here? I think there is square here at least. Is equal to 0. Why dy by dx plus e power t is no? Like if you have x here, I think there should be something x. Look, dy, let us suppose there is x here. Okay, for the time being, let us suppose there is x. So we have e power x is equal to 0. then dy by dx is equal to minus e power x. Correct? This is what you have. Okay, dy by dt, fine. Dy by dt, and this is also e power t. Okay, so now see carefully. Why this is non-homogeneous? See, dy by dt is equal to minus e power t, correct, which is minus of t minus, oh sorry, this is e power x, so 1 plus t by 1 factorial plus t square by 2 factorial and all. As our friend Kamaldeen told, we have a series expansion for this function e power t. Now you can see this dy by dt is equal to this complete expression, which is not a homogeneous function basically. Okay, so since this is not a homogeneous function, we say that this is not a homogeneous differential equation. Clear? Because if the function is to be homogeneous, definitely every term should be of same degree. But in Taylor series expansion of e power t, this is not the case. Okay, I'll upload the notes today, no issues. Apart from notes, is there any difficulty at any point? But of course, questions of differential equations are repetitive in nature, means you'll be solving same kind of question many of the times. So, but it can't be avoided because that's how questions are being asked in GATE examination in differential equations. Okay. I understand it won't be much interesting as in calculus with the graphs and all, but please wait till we start vector calculus. But till then, for today and tomorrow's class, please try to solve some questions of this kind. Can we have your contact details, sir? It's okay. I'll discuss with the people and I'll let you know. Okay. If it's possible, we'll try to create one group so that we can, you can discuss yourself some good questions and all in that. Okay. Fine. So we'll stop this lecture here. I think we have few more questions to deal with. So tomorrow we'll start higher order differential equations. Okay. So basically the second order differential equations, third order, and of some higher order. So please don't skip tomorrow's class. Okay. Yeah, I'll think of that, and if possible, we'll try to make one group so that you can discuss some good questions among yourself if you find them. Yeah, then thank you all. Good night. So please let's meet tomorrow and we shall continue the things. Okay. And if you are here for the first time, you please subscribe to the channel so that you will be getting notified whenever we are launching any courses, and you can follow it from the beginning lecture. Okay. So fine. Thank you all. Good night. We'll meet tomorrow 9 p.m. sharp. Thank you all.